evening and welcome. You know I wasn't going to leave you hanging, so just to make sure we understand a little bit more, I saw your faces, and I wanted to make sure we understand when we have the side angle case when we're dealing with triangles. These were the 6 cases that we had, and I want to make sure that we understand each one of the 6 cases. We did a problem with obtuse angles, and we tried to do a problem with acute angles. Not sure if it went over well, but we tried. So understand some of the things that we need in order to have a triangle, 2 triangles, or no triangle. We did an obtuse case, so let's talk about the acute case. We did this problem in class. With this problem, it kind of shows you what we needed to get where we needed. We have 2 sides, 20 and 11, and with all of that, we were able to find all the angles and all the sides. The reason why with that obtuse case right there is because A was greater than B. A was 20, B was 11, so therefore we have one triangle. If A was less than or equal to B, we would have had no triangles. That was the obtuse case. In the acute case here, actually let me erase this and go back over it again so you guys understand even more what's happening. So here in this acute case where our angle A is 51 degrees and A equals 3.5 and B equals 5. First off, let's draw our triangle. Well, let's draw pieces of the triangle. Let's draw the triangle to see what we'll end up with. So say, oh, that's not working well. All right, say we actually have a problem with, looks like angles 51 degrees. A is 3.5 and B is equal to 5. Now, let me zoom in just a little bit so you can see and understand that we want a 51 degree angle right here. So this would be A. That means this corresponding side will be A. This is B right here. That means that the angle over here, if we can make a triangle, that would be B, and C would be up here, that would be C. But using all of those, we're trying to solve the C, or see if we could solve it, right? Now, one of the important things to understand is that all of these triangles have a height, right? And if we split it right down the center like that, we form 2 right triangles. Now, one part that I want to show you is up here with each one of these cases. H equals B times sine A. We're actually going to use that with this. It might have been confusing when we did it in class, but hopefully this helps. So what happens is that since H equals that, and this is our right angle right here, B is our hypotenuse, H is one of the legs right here, right? So we just took the sine of 51 degrees. We end up with H over whatever B is, and B in this case is 5, right? So since that's the case, H equals 5 times the sine of 51, right? And from there, understand what that's going to give us. If you look here, we have 3.9. Okay, we have 3.9 right there. So that means that H is equal to 3.9. However, notice something. Remember in this problem that A equals 3.5, right? H equals, and that is not greater, but H, this is less than 3.9, which is, doesn't really matter all the other parts. But since that's less than, you understand that A is less than H. And if you go back up to the chart, in an acute case, if A is less than H, we have no triangle. And we are still able to find that from this part right here. So we'll call that no triangle. But we had to check to make sure because we weren't sure. All right, now down here, we can do a different problem. Say here, solve ABC with A equals 40 degrees, A equals 13, and B equals 16. Now this is the problem that some we left off on and some of you got a little hung up on. But I will show you what happens with this problem. Now notice, since in this triangle, remember, we should find the height. In finding the height, that will tell us more about this triangle. All right. So finding this h will tell us what kind of triangle we're going to have. Now, in finding this height, remember, we're talking about 40 degrees. Since we have 40 degrees here, we could do sine 40. Whatever sine 40 degrees is, that's going to equal h over 16, right? Since now h over 16, meaning that you have 16 sine 40 equals h, meaning that h equals 10.28, right? So 10.28. Now, we have all of those. Notice that a itself, which is 13, is in between 16 and 10.28. So that means that a is in between h and b. And if we scroll all the way up, what does it mean for h to be in between h and b? That means you have two triangles. So since you have two triangles now, let's first I want to diagram where those triangles are. First, you have this entire triangle, right? Then you have to understand that you also have this itty bitty triangle right here. Let me draw that better for you. That's a better drawing right there. So understand here you still have a is equal to 13. But the only difference now is this angle here and whatever c is. So since you have two triangles, you have to solve those separately. So here's the two triangles that I have. The two triangles I have is the regular triangle with the 40-degree angle, and the 40-degree angle with this. Keep in mind the sides are still the same, and the given angle is still the same. However, you're going to have a different angle B and a different angle C. So let's go about how that's actually going to be done. First, let's do the big triangle. So let me zoom out just a little bit. And from this triangle right here, you want to know angle B, so sine B over B is equal to 16. So over 16 equals sine 40, because this is A right here, over 13, right? So that means that sine B equals 16 sine 40 over 13. So you plug all of that in your calculator. You'll end up with, what's that, 0.79? So sine B equals 0.79. We take the inverse sine of both sides. B is just going to be the inverse sine of 0.79, right? Which is equal to, what was it equal to? 52.18. Right? So we have this angle right here, 52.18. And you kind of know how to find, based off of this, now you know how to get C and how to get angle C. On this side right here, the part that I really want to stress is from here, understand that this angle B and this angle B are reference angles of each other. So what you have to understand is that the sine of B, when they're reference angles, sine of B is equal to the sine of 180 minus B. Because sine is positive in the first and second quadrant. So it doesn't matter, you have to change the signs or anything like that. But understand that those two things are equal. So since in this big triangle right here, the angle B was 52.18, then over here, this angle is just going to be 180 minus that. which is equal to 127.82. So we have this angle. We have this angle. You can get C by just subtracting. And then you can just get that C. So basically what you're doing is you're solving both of them separately. Let me finish it so you can see what we get. And as you can see, all I had to find the angle C, all I had to do was just subtract. And then from there, just law signs again. I got C equals 4.27 over on this case. Here, it's not on here. It's going to obviously be different because the angle C is going to be different. So understand that you're solving both of those separately. And you're going to get two different answers for two different triangles. All right. So last thing I wanted to deal with is area. We actually did area in class, but I wanted to make sure we're all on the same page with this area. So it says find the area of ABC, where the area here is going to equal 100. I want to use, since I have A and I have B, I want to use this one. All right. You can use any one you want. You have a lot of options here for which one you're going to use, but I want to use that one. From here, if I can get angle C, I'm okay. So let's work on what we know. How about this? Let's work on getting angle B, and that might open up what we need. So from here, say sine 100 over 8 equals sine B over 5, right? So that means that 5 times sine 100 over 8 is going to equal sine B, right? So we got to find out what that is. We get that equals sine B equals 0.62. So from here, we're just trying to find the inverse sine of 0.62. And our angle measurement is 38.31. Let's just say 38.32 and round to the nearest hundredth. Now since I have that as my angle B, I can find C. That's just 180 minus 100 minus 38.32. If I calculate that, I get 41.68. So C is just going to be 41.68. So since I have C now and I can use that one right there, now my area is just 1/2. A is 8, so 1/2 times 8 times 5 times sine of 41.68. And I can find my area. Now keep in mind, I can do this for any one of them. So with all of this said and done, you guys should be able to do all of your homework now. I hope this helps. If you have any trouble, please contact me.